So in section 2-2, the graphical and algebraic approaches to the definition of a limit, we're going to use our epsilon delta definition of a limit that we learned in section 1-5. Okay? So below, we're going to see the graph of our function, f of x. So we know our function f of x is equal to this, right here. Tells us, right? Great. Now, you'll also notice when you look at the function that there's a hole in the function. So as a reminder, that type of hole is called a removable discontinuity. Okay, remember when you can fill a hole with one point, it's a removable discontinuity because that point is just removed from your graph. So in order to figure out our problem, the first part is to figure out what the limit is as x approaches 2. So if you're not looking at if you are looking at the graph, it's fairly obvious that at x equals 2, your hole's at 3. You're going to get closer and closer to 3. If you didn't want to do it by looking at the graph, you can also have plugged in the function, the original function, into your graphing calculator and use the trace feature to figure out what the value is of f of x as x gets closer and closer to 2. The third way is to plug 2 into your function and approximate what you think the value would be. So let's do it that way. So if we have f of 2, that would equal 2 minus 2 to the 1/3 power plus 3. So this whole term doesn't really make sense, but it's going to essentially be 0, right? 2 minus 2 is 0. The cube root of 0 would be 0. So we'd be left with 3. So our limit then, as x approaches 2, would be 3. So now, again, we're using our definition of a limit, our epsilon delta definition. So the second part says let epsilon equal 0.8. So that means that we want our values on our y-axis, our f of x values, to be within 0.8 of 3. So in order for us to look at this graphically, I'm going to zoom in on this graph. Whoop, too much. Okay, so I'm zooming in on my graph here. So remember that we already figured out, well, we figured out, I should say, that our limit right here is at 3, and that occurs when our x value approaches 2. So what the question's asking us is we want to figure out how far away from 2 we can get on our x-axis. So how far away, what is our range on our x-axis, right? What's our delta on our x-axis? So that our epsilon is with always in 0.8 of 3. If epsilon is with always in 0.8 of 3, that's going to give us a range from 2.2 to 3.8. Okay? So we need to figure out at 3.8, what's my x value? And at 2.2, what's my corresponding x value? Those corresponding x values will help us determine what our delta is. Okay? Remember, in case you forgot, our distance here is just your epsilon value. In order to solve this problem, I'm going to zoom back out. All we're going to do is replace our f of x value with 3.8. So to do that, I'm just going to literally replace it. So 3.8 is going to equal x minus 2 to the 1/3 power plus 3. Now, the reason I'm doing this is because I need to figure out what my x value is. So I'm plugging in my y value on my graph, and I need to find my x value. Okay, so it's a simple algebraic equation. I'll subtract 3 from both sides, and that will give me 0.8 is equal to x minus 2 to the 1/3. I'm going to cube both sides, because by cubing both sides, that will turn this exponent into a value of 1, which is what I want. When I go ahead and cube both sides, I'm going to end up with 0.512 is equal to x minus 2. Adding adding 2 to both sides will give me a value of x of 2.512. Has to be my x value. Now, if I zoom back in on my graph, that is this x value, okay? 2.512. That's the x value at that point, okay? So keep that in mind as we're working. We've now figured out knowing that our y value is 3.8, we figured out the corresponding x value, which is great. That gave us the upper bound for our x value. Now we need to figure out what our lower bound is. So we're going to do a similar process, but instead of replacing f of x with 3.8, we're going to replace f of x with 2.2. That would be my lower bound on my y-axis. So when I do that, I'm going to get 2.2 is equal to x minus 2 to the 1/3 power plus 3. If I do all the arithmetic, solving it by the same steps, my answer would be that 1.488 equals x. Great. So again, if I zoom back in on my graph, this value here, my lower bound on my x-axis, would be 1.488. Okay? So now, what the original question was asking us to do was find delta. So delta is my distance from 2. So I know how big 2 can be, which is 2.51. I'm sorry, 2.52. And I know how small x can be, which is 1.488. But that still hasn't answered the question, because what the question wants is this distance, okay? Let me get a different color here. The question wants this distance right here. That's my delta, and it will be the same on both sides. So all I need to do then is take my upper bound and subtract 2, or take my lower bound, take 2 and subtract my lower bound. Either option will work. So when I do that, let's get a new color. So if I just use my upper bound, I would get 2.512 minus 2 is equal to 0.512. Therefore, remember 3 dots means therefore, delta has to be within 512, excuse me. So let's take this answer back to the context of the original problem. So what the question was asking us was, how close does our x value need to be to 2 so that our y value can be within 0.8 of 3? That's what the question was. So if we're within 0.8 of 3, that means our x value has to be within 0.512 of x. Go ahead and try, whoa, I don't know how that just happened. Go ahead and try example 1 on your own, and I'll take questions on it tomorrow in class.